Hey everyone, Mr. Newman here, and today we're going to do average rate of change notes. So we're going to be able to recognize slope as average rate of change, and we're going to be able to calculate it and interpret it within a function. So first of all, you should know that average rate of change is basically how quickly a function increases or decreases. The formula for average rate of change is the change in y over the change in x. Now, mathematicians being lazy don't want to write down the word change every time, so we draw a little triangle like this. The triangle, it's the Greek letter delta, and so you can say delta y over delta x, that's what you'll hear me say, or you can also say change in y over change in x. And it's helpful to fall back on thinking of change because to measure change, of course, you subtract, and you'll see that happening a lot. But first, I'm going to address what is tricky about this formula. Well, when we're talking about x and y, you give a point, you say x comma y, x comes first. But in the formula here, for the rate of change, y is on top, so y comes first. So that's really what's tricky, and the most common mistake people make on these problems is putting delta x over delta y, even when they write delta y over delta x. So you'll see I'm going to strongly recommend that you always write that right there at the top of every single one of your problems so you do not mess this up. So let's do this on this first one. How to find, by the way, we're going to find average rate of change across three representations. We're going to do points, tables, and graphs. And they all are essentially the same way since those three things are three representations of the same thing. But let's practice them all so we get some practice. So you see the steps are subtract the y values to get delta y and subtract the x values to get delta x. Then you divide delta y over delta x. So I'm going to write down, first I'm going to label what my x and y is. Maybe you guys don't need this step, but just to show you on this first one, it is helpful. So always write down delta y over delta x so that you make sure y is on top and you don't mess up like the most common mistake in all these problems. Our delta y is how much the y changes. Well, to go from 4 to 0, you can write down 4 minus 0. To go from 5 to 3, you can do 5 minus 3. Notice something important here. The point 5 comma 4 is one of the points. The 5 and the 4 are right on top of each other. Okay. Likewise, the 3 and the 0, that's a point. So the 0 and the 3 go right above each other. You can actually do this in either order, and you'll see for the rest of this video, I'm actually going to do the second one minus the first one, because that is more common standard practice. But what you have to do is, whichever way you subtract them, make sure that if you write the first point first, you write it for the x and for the y. Well, from here on out, it's just calculating it. 4 minus 0 is 4, 5 minus 3 is 2, 4 divided by 2 is 2, and you always want to simplify it. That way you simplify your fractions. All right, let's move on to number 2 here, where I throw some negatives in. So like I said, often when you talk about change, you're doing the second one minus the first one. So I'll show you that here. So write delta y over delta x again, as you will for all of these problems. Here, I want to make sure I see the 3's are my x's. Negative 3 and 3 are x. Negative 2 and 2 are y. So the 2 and negative 2 are going to go on top. So let's take the second one and subtract the first. So 2 minus negative 1, and then 3 minus negative 3. Anytime you write a negative number, it's a good habit to write it in parentheses. That way you don't mess up. So the next most common thing in this situation is people write 2 minus 2. Well, we always subtract them, so that's where this minus comes from. And this 2 is negative, so that second one needs to be negative 2. So that's where the 2 minuses come from. If you don't do that, you're going to subtract the wrong way and get something that's incorrect here. So 2 minus negative 2 is the same as 2 plus 2. So we get 4 over 6. Of course, that's a fraction that can be simplified. So you simplify it, and 2/3 is our answer for the rate of change. For the next one, I just want to do one more of these and show you guys that these can be negative. Okay. So notice 4 and 7 is our delta y, so we're going to put that on top, whereas 3 and 8 are our delta x. I hope you notice I've been color coding these, but the 7 and the 4 are the delta y, so we're going to put those on top. Notice I'm doing the second one minus the first one, so 7 minus 4. And I also need to do the second one minus the first one for the x's, so 3 minus 8. Do not just do the bigger one minus the smaller one. That will get you the wrong answer here. Because 7 minus 4 is positive 3, but 3 minus 8 is negative 5. If you flip those the wrong way, you're going to get positive 5. Then have a positive fraction here where you should have negative 3/5. By the way, this is perfectly acceptable to write on quizzes and whatnot, but it's just better practice to write the negative out in front when you have a fraction like that. All right, go ahead and try that last one on your own. Great, hope you got that one right. Let's move on to how do you find it from a table? Well, when they give us a table, like I gave you here on the right, what you see is they'll say x equals one number and x equals another number. So we have x equals 0, average rate of change from x equals 0 to x equals 2. It's as simple as just finding the points where x is 0 and x is 2 on the table. And just like last time we found the average rate of change of 2 points, we have 2 points here that the table gives us. We're going to find the average rate of change again. So pretty much the exact same thing. If it helps you to write down 0,8 and then 2,4, by all means, please do that. I like using a table much more than points, so I'm actually going to look at the table and use the table. Of course, this coloring might be a little confusing because notice I wrote delta y here. Well, the delta y is not 2 and 4, it's actually 4 and 8. So let me recolor these. So see, 4 and 8 are the y's, so the change in y is going to be the 4 minus the 8. And the change in x is going to be the 2 minus the 0. This gives us a negative 4 over 2, which simplifies to negative 2. Now, I knew this was going to be negative. If you look here, because I saw from 8 to 4, that's going down on the table. It's decreasing from 8 to 4, where the x's are increasing. If this number was going up, then I would know that that rate of change would be positive. So it's a good idea to do a quick check. Make sure you have the positives and negatives set up correctly. Since this is pretty much the same thing as last time, I'm going to go ahead and erase this here and tell you to please try the rest of these on your own. All right, now that you've done that, let's look at a graph. Slightly different again, though much of the same. One thing to note, though, is another name for rate of change on a graph is the slope. Now, that will be helpful when you're dealing with lines, maybe not so much when you're dealing with average rate of change across something that's not a line, like we'll see on the right here. But you can still do this by making a table or making the points. Like I said, I prefer tables. So what I'm going to do is I'm going to identify the points here and then make a table out of them. So we want to find the average rate of change from x equals negative 1 to x equals 0. Let me mark down on the points on the graph where x is negative 1 and x is 0. So there's negative 1 and there is 0. Let's write down those points and I'm going to put them in a table. So we have negative 1 comma negative 3 and 0 comma negative 1. Again, let's start by writing delta y over delta x. Our delta y is going to come from the negative 3 and the negative 1. And I'm going to keep up with doing the second one minus the first one. So we get negative 1 minus negative 3. Again, if you forget to write those parentheses in there, it's likely you'll drop one of the negatives and have the wrong sign on that. Divided by negative 1, 0, the second one, minus negative 1. And again there, if you don't write the parentheses, you'll drop the sign. So remember, minus the negative is the same as addition, so we're going to get 2 over positive 1, which is just 2. Now looking at the graph, I know slope is rise over run. At least that's what some teachers use. I'm going to show you where that shows up here in the graph and how you can use this to your advantage to quickly check or simply answer this kind of question. Notice from those 2 points we labeled, this graph goes up a value of 2 and right a value of 1. Well, rise over run means that our rise, our delta y, our change in y, going up 2, and then right 1 is going to give us positive 2 over positive 1. Well, 2 over 1 is 2, just like we got. In fact, it's the exact same formula. Rise over run is another way of saying delta y over delta x. This is helpful for lines if you already knew how to find slope, because you could just measure the rise over run, divide them, and simplify it that way. That's a very fast way to calculate these. Go ahead and try on number 2. You can try calculating it either way using rise over run or delta y over delta x. All right, now that you have that, let's find the average rate of change of something that's not a line. So average rate of change, the key word is average, it's going to find the average between the 2 points again. So I need to write down the 2 points just like I did before. So notice the blue point is when x is -1. The red point is when x is -2. So our points are -1, 0, and 2, 3. Well, I can write down delta y over delta x again and calculate 3 minus 0 over 2 minus -1. Notice I'm doing the second one minus the first one both times. Notice it also matches up. 2, 3 is our red point. -1, 0 is our blue point. So those do match up there. And when you calculate that, you get a slope of 1. Well, where does that slope of 1 come from? If you were to draw an imaginary line in between those 2 points, that slope would have a rise over run of 1. You can also see it here. It's a rise of 3 divided by a run of 3. That's actually exactly the calculation we did right here. These are just the numbers to calculate that. So, slope is rate of change. You'll hear me say that over and over in the class. And you can go ahead and try this last one. Thank you very much for watching.